This one says find the domain of the following function. Remember that whenever you have something like this, you can't divide by 0, guys. So x cannot equal 5 because at x equals 5, you have a vertical asymptote. And then you have this expression x plus 2 on the inside of a square root. Well, remember that the expression of inside the square root, guys, it must be larger or equal to 0 because you can't take a square root of a negative number. So to figure out what this x value is, you just move the 2 to the other side. X is greater than or equal to negative 2. And there's my domain. X is greater than or equal to negative 2, but it cannot equal 5. So how would I write this in terms of interval notation? So in interval notation, you would write it like this. You put a bracket, you put negative 2, comma, you go all the way to 5, parenthesis, union, and then you just put 5 and then infinity because it goes forever. And the reason why you have a 5 in parentheses and not a bracket is because you cannot equal 5. And this is called interval notation. Interval notation. All right, guys, let's go to the next one. Suppose that y equals f of x is an even function. So even function properties is this. F of negative x equals f of x. That's a property for even. And in case you're wondering what's the property for odd, the property for odd is f of negative x equals negative f of x. And really, I should be putting an a instead of an x, but oh well, too bad. So even functions are symmetric about the y-axis, and odd functions are symmetric about the origin. And it says if I have a coordinate, 6, negative 5 is a point on the graph of f, which of the points is also on the graph of f of x? All right, well, let's think about it, guys. 6, negative 5 is down here. And we're symmetric. This is an even function, which means symmetric about y. Symmetric about y-axis. So since we're symmetric about the y-axis, pretend that you're folding that green line there. And if you fold that green line, I'm going to be right here. And that's going to be at 6, negative 5. And there it is. That's it, guys. And it says, which of the given points, like we have multiple choice. We don't have multiple choice. So there it is. This is coordinate, guys, 6, negative 5. That's the coordinate that is also on F because we know that we have this coordinate there. And let's keep going, guys. All right. So it says this one, it says determine whether the following function is even, odd, both, or neither. Now, here's the property for odd. In case you're wondering how an odd function looks like, I'm not saying this is that function. I'm just saying, I'm just giving you guys how an odd function looks like. An odd function is symmetric about the origin. So, well, okay, I made this part not look as good, right? All right, so what that means is, and this is not a mathematical term, so don't memorize this word by any means, or don't call that out on, like, don't talk to a professor and say, oh yeah, professor, this is flip. So what I mean by flip is if you were to take this part in green here, guys, and I were to flip it across any axis, it doesn't even matter which one. So if you do the x-axis, if you flip it across the x-axis, it's going to be right here. And then look, it says second flip. So now flip it against the other axis that you haven't done. So if you flip it on the y-axis, it's going to overlap. So that's what it means by flip. When you flip, if you see it this way, if it looks like this one exactly, it's going to be an odd function. And odd functions, in order for it to be an odd function, it must go through the origin because it's symmetric about the origin. So odd functions must go through the origin. So I'm gonna test this out right here, guys. So I'm gonna type in a negative x, and I'm gonna see what I get. Well, I'm gonna test both of these out, I guess. See how I have a negative x in there, and I'm gonna see if I get the original function or if I get a negative on the outside. So I'm gonna type 5 negative x to the 5th power minus 4 negative x to the 3rd power. And then all you do, guys, you just go negative times a negative times a negative times a negative times a negative is a negative. So negative times a positive is a negative. So you're going to have negative 5x to the 5th. And then I'm just doing this part right here. That's going to be negative. And negative times a negative is a positive. So I'm going to have plus 4x to the cubed. And then look, guys, that looks exactly like that, but the polarities are opposite. So that means I can factor out a negative, and I would have 5x to the 5th minus 4x cubed. Well, this right here was f of x. Look at that. That's f of x. So essentially what you have this, f of negative x equals negative on the inside, I have f of x. See? Because you have this is an odd function. Does that make sense to everyone, guys? You guys there? Or am I talking to myself? You guys watching TikTok videos or something? Yeah, don't be watching that, guys. At least not right now. Let's try and focus on this because we're going to have an exam probably next week for you guys. And it's going to be all on this. So it should be pretty easy, guys. It's just like an algebra review. State the translation of the key point 0, 0. And you have a square root function. So what they're talking about is the parent function, guys. They're talking about the parent function y equals square root of x. So the parent function y equals square root of x starts like this. You start at the origin and there it is. So how does this function look without a calculator? Well, the way you can do it, guys, is like this. You say f of x equals the square root, and I'm going to factor out a negative so I can turn that x into a positive. I'm going to have x minus 2 plus 4. So all of this should be reviewed for you guys. So that x minus 2 on the inside, that just does horizontal shift right 2. And then this plus 4 on the outside, oh, okay, I guess I should talk about that negative. So that negative there makes it open leftward instead of open right. Opens, and I don't know if leftward is a technical term. And then that plus 4 is a vertical shift up 4. Vertical shift up 4. So now that you know that, here's how it looks. You have a graph. You're going to go 2 to the right and 4 up, 2 to the right, 4 up. So that point there is at 2, 4. And then you just go forever to the left like that. See? And they wanted the translation point of 0, 0. So they're talking about this point specifically. So I went from 0, 0 to 2, 4. So there it is. This is your answer. Does that make sense to you guys? You can unmute your mic and say yes or no.
Yes.
Okay, awesome. All right, which of the following functions are 1-to-1? This is pretty straightforward, guys. Remember, for it to be a 1-to-1 function, well, all these are functions, first of all, so they all pass vertical line test, but it must also pass a horizontal line test for it to be 1-to-1. So I'm going to put must pass vertical and horizontal line tests. They all pass vertical because they're all functions. So really, it must pass a horizontal line test. So number 1, it's a linear function. You don't even care what type of linear function, you just know it's a linear function. And yes, I know, guys, that if I wrote the y-intercept there, that's wrong because it says minus 4. Is a linear function 1-to-1? Yes or no? Uh-oh.
Yes.
Yeah, it is, guys. This is a cubic function. All that happens there is you move twice to the right. So here's how cubic functions look like. And if you want to move that twice to the right, that's fine with a vertical stretch of 5. Is a cubic function 1-to-1?
Yes.
Yeah, it is. It passes the vertical and horizontal line test. What about absolute value? So let's see. Let's draw an absolute value curve. So boom, boom. Is the absolute value 1-to-1?
No.
No. Yeah, it's not. And then the last one's a square root function with a vertical stretch of 3 and a horizontal shift of 2 down. You don't have to necessarily show that, but I guess we can try there. All right, that's my square root function. What do you guys think about the square root function? Is it 1-to-1 or is it not 1-to-1?
1-to-1.
Yeah, heck yeah, it is. It's 1-to-1. So 1, 2, and 4. And there it is, guys. All right. On this one, I wasn't actually going to type this in. If you're wondering why is it red there, it's because I stole this question from UH, from a UH quiz. So someone marked that question and they got it wrong. So here's what I would have liked to have seen, and yes, I know that you guys could just look at the patterns and probably already predict which is the right answer. But on an exam, I'm gonna wanna see these patterns, guys. You tell me what f of x plus h is somewhere, and it's 4 over parentheses x plus h close plus 3. You can drop the parentheses, x plus h plus 3. And then here we go. I'm gonna go ahead and write this statement. F of x plus h minus f of x all over h equals, and then I write what f of x plus h is, which is 4 over x plus h plus 3 minus, and then I write what f of x is, 4 over x plus 3. And all of this is over h. Now that you got it up to here, now we need to do some algebra. So you're going to multiply the right dude by x plus h plus 3 over x plus h plus 3. And you're going to multiply the left dude by x plus 3 over x plus 3. And then once you do that, here's what you're going to get. I'm going to put the equal sign. And I guess we can show the distribution like so, over x plus 3, x plus h plus 3 minus 4 parentheses x plus h plus 3 over x plus 3, x plus h plus 3. And all this is still over h. So I'm trying to show all the details. So from there, and I guess I should have put the equal sign more like right here, right? Because that's the middle there. From there, I'm going to go ahead and start distributing. 4x plus 12. And then I'm going to write minus. That minus is this minus. And I'm going to put parentheses. 4x plus 4h plus 12 all over, here's my common denominator, x plus 3, x plus h plus 3, and I'm going to bring that h up. So h. And that's from the keep, change, flip deal. See notes, see video of notes. I think it was notes, notes 1. Notes 1 or 2. I don't remember. One of those two. Oh, wait. This is notes 2.5, so it has to be in notes 1. See a video of notes 1 on how we did that. If you have questions on how we did that, guys, I can answer it after we're done with the lecture. I just don't want to keep the class. I want to pay respects to your asynchronous time. Then I'm going to distribute this negative. So here we go. 4x plus 12 minus 4x minus 4h minus 12 all over x plus 3, x plus h plus 3, and then the h there. And now I can zero out what zeroes out, guys. I have a 4x here. I got a 4x there. I got a positive 12. I got a negative 12. I got an h. I got an h. And, well, the only reason why those h's cancel out is because I only had one term left. So now, here's my answer. I have 4, negative 4 over x plus 3, x plus h plus 3. And we'll look for that answer, guys. Are we feeling okay, guys?
Yes.
Okay. Awesome, awesome. Let's keep going. This stands for inverse. And hopefully you remember that for it to be an inverse function, it reflects across the line y equals x. So having said that, a quick little review. If I have a curve and I call this point A comma B, then the inverse of that point on that curve is B comma A. You just toggle the x and y coordinates. So having said that, it says find the linear function f, so they want our original, if they inverse point, so I have an inverse point to -1 and 7, 3. Okay, so the way we're gonna do that, guys, is I'm gonna toggle these points to find the original on f. So points on f are -1, 2 and 3, comma 7. So these are the points that I'm going to be working with. And by the way, this graph there is not a linear line. I just did that for illustration purposes, guys, just to give you guys a background. All right, so now that I know that it's those points that I'm working with, I'm going to find my slope. So I'm going to do the change in y over the change in x's. So 7 minus 2 over 3 minus a negative 1. 7 minus 2 is 5. 3 minus a negative 1 is 4. And then I delete anything that does not have a slope of 5/4. Out, 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 maybe out. So it's between B and F. It's very rarely ever F, guys. Although I did play a prank on my seniors like 6 years ago. And I made a quiz. And every single answer on that quiz was none of the above. And I had a good time. My kids probably did not have a good time, but I had a good time. And I didn't count it for a grade, so I don't want you guys to think like, man, this guy's just evil. Like, no, I just did it because, you know, I wanted to have a good time. It was close to April Fool's Day, but I couldn't do it on April Fool's because they would know it was not a real quiz. So I had to do it like a few days right before. And that was my April Fool's in advance. Anyways, let's get back to this question here. I already know that this is my slope. I have an idea that the answer is B. I'm going to use my point slope formula. I'm going to use that 3, 7. So I'm going to write y minus 7 equals 5/4 x minus 3. And let's see if we get that 13 over 4 there. Y minus 7 equals, that's an equal sign, it just came out dumb, equals 5/4 x minus 5 times 3 is 15. 15 over 4. I'm going to add 7, add 7. I need to turn that into a fraction, so just multiply by whatever that denominator is. 7 times 4, what's that? 7, 14, 28, so 28 over 4. So the difference between 15 and 28, let's see, 15, 25, 16, and 28. Yeah, it's 13, positive, by the way, because 28 is bigger than 15. So y equals 5/4 x plus 13, and you keep the denominator over 4. Hey, guys, we did it. We did it. All right, let's keep popping. Composite functions, I think you guys are pretty good at composite functions. Sometimes you'll see a textbook that will have it like this. Don't freak out. That means it's still a composite function with respect to x. That's all it means. So that means this. It's also the same thing. If you don't see the x in there, relax. It means this. See? So what do I have on the inside? So you have a function within a function, functionception. If you haven't seen the movie Inception, you're not going to get that joke. But if you have seen it, then maybe you chuckled or maybe you thought it was lame. And in that case, well, I apologize. But you know what? I don't have to apologize. I'm not going to apologize. So I'm going to insert g of x into f. So here's g of x. It's 5x minus 2. So I'm going to write f of 5x minus 2. And then I look at my f function. And wherever I have the variable x, I'm going to insert 5x minus 2. So I'm going to write 5x minus 2, close it, put a square on it. I'm going to put plus 2, parentheses, 5x minus 2, close it. And now that I'm done, all we're going to do now is just algebra. So here we go. I'm going to do algebra. 5x times 5x, 25x squared. 5x times a negative 2. I'm just foiling, guys. I'm just foiling. 5x times negative 2 is negative 10x, but I'm going to have 2 of those. So I'm going to write minus 20x. Negative 2 times negative 2, that's a positive 4. And then just distribute this 2 dudes. Plus 10x minus 4. All right, finally, I can see that stuff is going to zero out. So let's see. The 4 zero out, and then just combine these two. So I'm going to write my final statement. I'm going to say that f of g of x is nothing more than 25x squared minus 10x. F composite of g. Everything was clear there, guys? Was everything clear there?
Yes.
Awesome, 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 awesome. All right, letter B. It says g f of 5. So I'm going to find f of 5 first, and then whatever that is, I'm going to plug it into g. And hopefully we won't need a calculator. G And let's see, what's f of, I guess I'll do f of 5 here on the side. F of 5 is, what happened there? Okay, f of 5 is 5 squared plus 2 times 5. 25 plus 10, 35. So there it is, f of 5 is there on the side. So I'm going to write g of 35. Okay, well, g of 35 is, let's see, equals 5 times 35 minus 2. Ooh, big numbers. Let's see. 35 plus 35 is 70, so that's 35 times 2. So if it's 70, 35 times 4 must be 140. And then I can add 35 to the 140. 140, 50, 60, 70, 75. 175 minus 2 is 173. There we go, guys. See, we didn't need no fancy calculator. And if you want to make your final statement, you can say G f of 5 is equal to 173. I think that was pretty straightforward. I think most of you guys are pretty good at that one. All right, back to inverses. Obviously, I did a bad job of titling it. If I call this the inverse function, and yet I had an inverse function way up here. So as you can see, I didn't do the best of jobs when I typed out these notes. My bad, guys. I was typing these out probably like close to 2 in the morning. So give me a break this time, just for this once. I can tell you why. Okay, side note, I'm usually pretty efficient with my time, guys. I really am. I actually pride myself in being efficient with my time. But lately, I've been getting distracted by, I love dogs, and I love puppies, and I love cats, and I love kitties. So I've been getting distracted with YouTube videos of dogs and cats and puppies. And before I know it, like instead of just spending 2-3 minutes watching puppy videos, it's been an hour, and an hour passed, and all I've done is watch puppy videos, which is, it's a good way to, I guess, waste an hour. But yeah, I need to stop that. All right, so let's get back at this, guys. So sorry for that little sidetrack there. So that -4 was a y on f. So I'm going to say that in here. This number, or I guess I can write -4. So I write -4 was, not was, is a y value. Is a y value on f, f of x. All right, since I know that it's a y value on my function, that's what I'm going to look for. So let's see, here is my y value of my function. What they want to know is, on the inverse function, when x is -4, what's the y value? Well, the y value for the inverse function has to be -2. So there it is. Inverse of -4 is simply -2. Chavez, I don't understand. Why? Can you explain? Yeah, of course. Remember that in order for you to have an inverse, that it has to reflect across the line y equals x. So you can see that those points are just toggling. They're just flipping. The x becomes your y coordinate, the y becomes your x coordinate. All right, continuing, f and g are inverse functions. So since they're inverse functions, you can say, you can put it on the side here that g of x is equal to the inverse of f. So now that you know that, f is 5, 2. This right here is 2, -3. So this is the same thing as saying, what's the inverse function of 2? When x is 2, what is the y value of the inverse function? So remember, that 2 was a y value on the original, or on f. There it is. There's my y value of 2 on the original. So it better output 5. And there it is, guys. Another one. Another one. All right. I think this is the last one. Yeah, we're doing good timing, guys. Find the inverse of this function, square root of 2 minus 4x. If possible, don't forget to state the domain. So real quick, I'm going to go ahead and state that first. So I'm going to say this. I'm going to say the range of f of x is the domain of the inverse. And you say inverse by f to the power -1. And why is that? Because range is y values and domain is x values. So remember that your y values of x are your x values. Did I say that right? The y values of f of x is your x values of your inverse function. And your x values of your original function, f of x, are your y values of your inverse function. Because they just toggle, they're flip-flop. So it's a square root function. Hopefully you have a little knowledge about what square root, how square root looks like. The smallest you can have, the smallest number you can have inside of square root is 0. So that means my domain, so this right here, the smallest value of my range is y is greater than or equal to 0. So since this is my range, that obviously is my domain for the inverse. So I'm going to write hence domain of the inverse function is x greater than or equal to 0. All right, now let's do the fun part, which is just doing the algebra stuff. So remember, it reflects across the line y equals x. That means we can interchange x and y. So since this is like y equals, I'm going to say x equals square root of 2 minus 4y. And what we're doing now, we're just going to solve for y. I want to get rid of the square root. So I put a square. I put a square. Whatever you do to one side, you do to the other because they're equal. So now I'm going to write x squared equals 2 minus 4y. What I'm going to do now is move the 2 to the left. When I do that, it's going to turn negative. So I'm going to write it as x squared minus 2 equals a negative 4y. I don't see any mistakes. I'm going to divide by negative 4. And I'm going to rewrite it, guys, with the y on the left-hand side. So I'm going to write y equals x squared minus 2 over negative 4. If you're like my professor, you probably want to put that negative sign on the very front, but make sure it's in the very front and it won't be confused with negative, like with saying negative x squared. I'm going to leave it like that. Since this is inverse, I want to say that. So I'm going to say x to the negative 1 of x equals x squared minus 2 over negative 4. No one's going to confuse that negative. It is definitely tied to that 4. If you want to write it in the very front, make sure you write it like that. And then x squared minus 2 over 4. So there's no confusion. You know, there's no confusion if you do it like that. But if you write it right here, well, look, if you write it like that, that looks like it's x squared that's negative. So you got to be careful. So either write it like this in the very front or just leave it with that number 4. No big deal. All right, guys. We're pretty much done. So let's all come back.